snowball from another star system, hurtling through our cosmic backyard and acting weirder than any comet we've ever seen. Hit subscribe to get the latest updates about this cosmic traveller. In the vast, dark emptiness of space, our solar system is a tiny island of light and warmth. It is our home. We understand its rules. We know its residents. We have studied the planets, the asteroids, and the comets that circle our sun. We thought we had a good idea of what to expect. But space is full of surprises. Sometimes, a visitor from far, far away decides to drop in, and when it does, it can change everything we thought we knew. This is the story of one such visitor, a traveller from an unknown star on a journey that brought it blazing through our cosmic neighbourhood. Its name is 3I Atlas, and it is not like anything we have ever seen before. This is the story of our mystery guest from another star. This strange object, officially named 3I Atlas, is an interstellar comet. That name tells you the most important thing about it. Interstellar means it comes from the space between the stars. It was not born here, in our solar system. It was formed around a completely different sun, in a place we can only imagine, and now it has found its way to us. Its journey has been long, travelling for millions of years through the cold, dark void. But its journey is far from over. In fact, the most exciting part is happening right now. 3I Atlas has already zoomed past the orbit of Mars. It is now speeding towards the Sun, getting closer every single second. This is a critical moment for any comet. It is the time when the Sun's power truly begins to take hold. For any object travelling from the outer darkness, this is the most intense phase of its journey. The Sun is like a giant furnace at the centre of our solar system. The closer you get, the more you feel its heat. The closer you get, the more you feel its immense gravity pulling on you. For a fragile ball of ice and dust like a comet, this can be a very dangerous time. The heat can make it burst with activity, the gravity can tear it apart, and 3I Atlas is already showing signs that it feels the pressure. It is already behaving in very strange ways. It is not following the usual script for a comet. It is writing its own rules. The things it is doing are making scientists all over the world stop and watch. They are confused, and they are very excited. This comet is a puzzle. What are these odd activities? For one, it is blasting out huge amounts of water into space. This might sound normal for a comet. Comets are often called dirty snowballs for a reason. They are made of ice, and when they get warm, the ice turns into gas. But 3I Atlas started doing this far away from the Sun. It was still in a very cold part of space, where the Sun's warmth is weak. Most comets from our solar system would still be frozen solid at that distance. They would be quiet and inactive, but not 3I Atlas. It was already waking up. It was already putting on a show, and that was just the first clue that something was different. The second clue was even more surprising. When astronomers looked at the cloud of gas around the comet, they found something unusual. This cloud is called a coma. It is like an atmosphere that forms around the comet's solid centre as it heats up. The coma of 3I Atlas was packed with carbon dioxide. Carbon dioxide is the same gas that makes Soda-Fizz. On this comet, there was a lot of it. Far more than we see in most comets from our own solar system. This strange recipe, with so much carbon dioxide and so much early activity, points to one very strong conclusion. This unique behaviour strongly suggests it didn't come from our solar system. A comet from our neighbourhood would have a different chemical makeup. It would follow a different set of rules. It would wake up closer to the Sun. Its gas cloud would have a different mix of chemicals. 3I Atlas is different in every important way. It is like a tourist from a country we have never visited, speaking a language we have never heard. It is a piece of another star system, delivered right to our doorstep. This is an incredible opportunity for science. It is a chance to study a piece of the universe that is normally far beyond our reach. Because of this, astronomers are watching its every move. They are using the most powerful telescopes on Earth and in space to keep a close eye on it. They want to see what happens as it gets even closer to the Sun. The Sun's intense heat and radiation will be the ultimate test for this strange visitor. Will it become even more active? Will it break apart under the strain? Or will it reveal even more secrets about its mysterious past? The journey of 3I Atlas into the heart of our solar system is more than just a beautiful sight in the sky. It is a scientific investigation. It is a deep space mystery that is unfolding right before our eyes. The clues are coming in, piece by piece, as this messenger from another star gets closer to its moment with our Sun. Every new piece of information helps us understand not just this comet, but the wider universe it came from. The story is just beginning. What this icy visitor reveals might change our understanding of how solar systems are born. The intense scrutiny of this object is for good reason. Every detail matters: its speed, its path, its chemical signature. Each observation is a page in a book we've never read before. A book about a different cosmic neighbourhood. Scientists are trying to read this book as fast as they can, before the comet speeds away, gone forever. The pressure to learn as much as possible is immense. This is a rare chance. We don't know when the next visitor like this will arrive. It could be years, it could be decades. So, the world's astronomical community is united in this effort. They are sharing data. They are working together to solve the puzzle of 3I Atlas. The excitement is real, because this comet is not just a rock. It is a time capsule. A time capsule from a place and a time we can only dream of. What secrets does it hold inside its icy heart? As it flies toward the Sun, we are hoping it will give us some answers. The journey ahead is dangerous. The forces of the Sun are powerful and unforgiving. The comet's strange nature makes it unpredictable. We are watching a high-stakes cosmic drama, and the main character is a small, frozen traveller from an unknown home. Its composition is a direct link to its birthplace. The chemicals locked in its ice are the same chemicals that were present when it formed, billions of years ago. By studying these chemicals, we can get a glimpse into the environment around another star. Was that star system rich in carbon, like this comet suggests? Was it colder than our own solar system when its planets were forming? These are the kinds of questions that 3I Atlas can help us answer. It is a scientific treasure, a gift from the galaxy. The sheer amount of water vapour it was releasing was staggering. At 40 kilograms per second, this was no small leak. It was a torrent. Imagine a large car being turned into vapour every minute. That is the scale of what was happening, and it was happening in the cold depths of space. This activity so far from the Sun was the first major red flag for astronomers. It told them immediately that this object was not playing by the local rules. Our comets need the Sun's heat to be much stronger before they put on such a display. They need to cross an invisible line in space known as the frost line, where water ice can finally turn to gas. 3I Atlas seemed to ignore that line completely. It was as if it came from a place where the rules of physics worked differently, or at least the ingredients for comet making were exotic. This unusual activity hints at a formation in an environment very different from our own. Our solar system had a specific temperature and chemical gradient when it was young. Comets formed in the colder outer regions, but they still inherited a certain chemical balance, a balance that we have come to recognize as normal. 3I Atlas throws that definition of normal out the window. Its high carbon dioxide content suggests it was born in a place that was extremely cold, a place where carbon dioxide could freeze into solid ice just as easily as water. This points to a formation far out in its home star's planetary disk, or perhaps around a star that was much cooler than our own Sun. Every clue it gives us is a clue about its home. So as it barrels toward its closest approach to our Sun, the anticipation grows. It is a scientific experiment of cosmic proportions. We are providing the heat source, the Sun. And 3I Atlas is providing the unknown material. The reaction between the two is what everyone is waiting to see. The data gathered during this encounter will be studied for years, maybe even decades. It will be compared to the data from our own comets. It will help us build a better picture of the variety of worlds that exist in our galaxy. We're not just looking at a comet. We are looking at a piece of a puzzle that is as big as the Milky Way itself. The story of 3I Atlas is our story too. It is the story of how star systems connect, and how the pieces of one world can end up visiting another, across unimaginable distances of space and time. This journey is a testament to the dynamic and interconnected nature of our galaxy. We are lucky to be here to witness it. But what makes this icy visitor so different from anything else we have ever seen, and what might it reveal about the universe beyond our Sun? The question of its origin and journey is fascinating. How does an object like this get sent on such an incredible trip? The answer lies in the chaotic dance of gravity that happens in young star systems. When planets are forming, they move around a lot. Sometimes a giant planet can move into a new orbit and act like a gravitational slingshot. It can grab smaller objects like comets and fling them out into interstellar space at incredible speeds. This is likely what happened to 3I Atlas. It was probably a normal member of its own solar system, quietly orbiting its star. Then, one day, it had a close encounter with a large planet, and its life changed forever. It was ejected from its home, sent on a random walk through the galaxy. A journey that, by pure chance, brought it to our doorstep. This makes 3I Atlas not just a visitor, but an exile, a piece of a long-lost world. Its journey through our solar system is a brief moment in its long existence. For us, it is a major event. For the comet, it is just a short, fiery interruption in an endless voyage through the dark. After it passes our sun, it will continue its journey. It will head back out into the void, never to return. We have this one chance to study it, this one chance to learn its secrets. The telescopes of the world are pointed its way for this very reason. Every photon of light collected from it is precious. Every piece of data is a victory, because when it is gone for good. The mystery it presents is compelling, the science it offers is invaluable, and the show it is about to put on could be spectacular. The story of 3I Atlas is a reminder that the universe is a big, strange and wonderful place, full of surprises waiting to be discovered. The tale of this remarkable object is a classic story of scientific discovery. It is about being in the right place at the right time with the right tools, but it is also about knowing what to look for. Astronomers have been scanning the skies for objects like this for years. They knew that visitors from other stars must be passing through our solar system all the time, but finding them is incredibly hard. They are small, dark, and moving very fast. It is like trying to find a single black baseball thrown through a giant dark stadium at night. The fact that we have found 3 of them now is a testament to how much our technology has improved. So let us look at the moment this particular story began. Let's explore the tale of how we discovered our 3rd interstellar visitor. The saga of 3I Atlas began on a summer night in July 2025. While most of the world was asleep, a network of robotic telescopes was busy doing its job. These telescopes were not looking for anything in particular. They were simply scanning the entire night sky, over and over again. They were looking for anything that moved, anything that was different from the night before. This constant watch is how we discover new asteroids and comets. It is our planet's early warning system for anything that might come too close to Earth. But on this night, the system would find something far more special. It would find a ghost from another star. The discovery was not a dramatic flash in the sky. It was quiet. It was just a few pixels of light on a computer screen, but those few pixels would soon capture the attention of the entire world. The discovery was made by astronomers in Hawaii. They were using a special system called the ATLAS survey. ATLAS stands for Asteroid Terrestrial Impact Last Alert System. Its main job is to find dangerous asteroids, but it is so good at its job that it finds all sorts of other interesting things too. On that night in July, the ATLAS computers flagged a new object. It was a tiny, faint dot of light. At first, it probably did not seem very important. The system finds new objects all the time, but as the astronomers watched it over the next few nights, they noticed something very unusual. It was moving incredibly fast. It was moving much faster than anything that belongs in our solar system should be moving at that distance from the sun. This speed was the first big clue. It was a hint that this was not a local object. It was a traveller from the great beyond. This initial hint was soon confirmed by math. When astronomers tracked the object's path across the sky, they could calculate its orbit. The shape of that orbit tells you everything you need to know about where an object comes from and where it is going. Objects that belong to our solar system travel in closed orbits, like circles or ovals. They are trapped by the sun's gravity, destined to circle it forever. But this new object was different. Its path was what scientists call a hyperbolic orbit. You can think of it like this. If you throw a ball up in the air, gravity pulls it back down. That is a closed path. But if you could throw a ball so fast that it escaped Earth's gravity completely, it would fly off into space and never return. That is an open path, a hyperbola. This immediately confirmed that the object was not gravitationally bound to our sun. It was just passing through. This was the moment of proof. It meant the comet came from another star. This confirmation was a huge deal. This object, now named 3I Atlas, became only the third confirmed interstellar visitor we have ever found. The first was a strange cigar-shaped object called Oumuamua, which was spotted in 2017. Oumuamua was a complete mystery. It did not act like a comet or an asteroid. It just sped through our solar system and was gone before we could get a good look at it. The second visitor was 2I Borisov, found in 2019. Borisov looked and acted much more like a regular comet. It had a tail and a coma. It was our first chance to study a comet from another star system up close, and now we had a third. 3I Atlas joined this very exclusive club. Each new visitor is incredibly important. With just one or two, it is hard to know what is normal and what is weird, but with 3, we can start to see patterns. We can start to build a real understanding of what these interstellar travelers are like. After its discovery, every available telescope turned to look at 3I Atlas. We started to piece together the story of its journey. We learned that it had been travelling toward us for a long time. Its path brought it into our solar system from above, diving down toward the Sun. In early October, it slipped across the orbital path of Mars. This was a significant milestone. It was now officially in the inner solar system. Around this time, a spacecraft that was already orbiting Mars got a chance to take a look. Europe's ExoMars Trace Gas Orbiter pointed its camera toward the visitor. The picture it took was from very far away, so the comet was still just a dot. But it was an interesting dot. The image showed no tail. A comet this active should have already had a tail of dust and gas streaming behind it. Instead, all ExoMars saw was a bright, compact gas cloud. This was another early sign that 3I Atlas was a bit of a strange character. Its story was getting more interesting with every new observation. The discovery was a triumph of technology and persistence. The Atlas telescopes are not giant, famous instruments. They are relatively small and work together as a team. But their constant, tireless scanning of the sky is what makes discoveries like this possible. It is a reminder that in astronomy, sometimes the most important discoveries come from just being patient and watching carefully. The universe is always sending us clues. We just have to be looking in the right place at the right time to catch them. The discovery of 3I Atlas was one of those moments, a faint speck of light that turned out to be a messenger from another world. The speed of the object was the critical factor. Local comets from the Oort cloud, a giant shell of icy bodies far beyond Pluto, can also come in on very long paths, but even they are still bound by the Sun's gravity. They have a speed limit. 3I Atlas was breaking that speed limit. It was moving with an excess velocity, a term that means it had extra speed that could not have come from our Sun's gravity. That extra speed was the leftover energy from its ejection from its home star system. It was its ticket to travel the galaxy. The calculations were checked and double-checked by astronomers around the world. The result was clear. This was the real deal, an object from interstellar space. The naming of the object also tells a story. The 3I means it is the third interstellar object ever discovered. The Atlas part of its name honours the telescope system that found it. This is a common tradition in astronomy. The discoverer gets to have their name attached to their discovery forever. So the Atlas survey, designed to protect Earth, had instead made a discovery that reached across the stars. It was a beautiful and unexpected result. It showed how different areas of science can sometimes overlap in surprising ways. A system built for planetary defense ended up giving us a priceless look into the nature of other solar systems. The comparison to the previous two visitors is important. Oumuamua was a puzzle that still haunts astronomers. Was it a nitrogen iceberg? A piece of a shattered alien planet? We may never know. 2I Borisov was more familiar. Its chemical makeup was very similar to our own comets. It suggested that maybe comets are made the same way everywhere. But now 3I Atlas has arrived, and it is weird in a completely different way. It is not a strange rock like Oumuamua, and it is not a normal comet like Borisov. It is something in between, something new. This is why having more examples is so important. It shows us that the universe is more diverse and more creative than we could have imagined. There is not just one way to build a solar system. There are many, and 3I Atlas is a perfect example of that. The distant picture from the ExoMars orbiter was another piece of the puzzle. The lack of a tail was confusing. If it was blasting out so much gas and dust, where was the tail? This suggested that the dust particles might be very heavy, or that the gas was expanding in a very uniform spherical way, or perhaps it was just too early, and the pressure from the sun's light had not had enough time to push the material back into a classic tail shape. Whatever the reason, it was another mark in the weird column for 3I Atlas. It seemed that every time we looked at this object, it gave us a new question to think about. It was a mystery that just kept getting deeper. The initial discovery was just the first chapter. The real story was in the details that would be revealed as it got closer, and we could study it with more powerful tools. The comet was here. It was confirmed as a visitor from another star, and it was acting very strangely. The stage was set for a much closer look at this cosmic guest. After the initial excitement of the discovery, the real work began for scientists. They needed to figure out what this strange visitor was made of. A comet's true nature is hidden in the light it gives off. By studying that light, we can understand its secrets. So, the world's biggest telescopes turned their gaze toward 3I Atlas. They were about to perform a deep chemical analysis from hundreds of millions of miles away. What they found would only deepen the mystery. It turned out that this was a comet that was all fizz and no sparkle, at least at first. Its behaviour was unlike anything seen before. To understand the comet's makeup, astronomers used powerful tools on the ground and in space. The James Webb Space Telescope, our most powerful eye in the sky, joined forces with giant telescopes on Earth. They performed what is called a spectroscopic deep dive. Spectroscopy is a clever way to figure out what something is made of just by looking at its light. It works like this. Every chemical element and molecule absorbs and gives off light in a very specific way. They leave a unique pattern, like a barcode, in the light's rainbow of colours. By capturing the light from 3I Atlas and spreading it out into a spectrum, scientists could read these barcodes. They could see exactly what kinds of gas and dust were in the comet's coma. It was like a long-distance chemistry experiment. The first and most stunning result from this deep dive was about water. The analysis revealed that 3I Atlas was puffing out huge amounts of water vapour. It was like a space humidifier on overdrive. The measurements were precise. The comet was releasing about 40 kilograms of water every single second. To put that in perspective, that is like the weight of a teenager turning from solid ice into gas every single second. This was a massive amount of activity. It explained why the comet's coma was so bright. It was a thick, dense cloud of water vapour, expanding out into space. This finding was exciting, but it also raised a very big question. That question was all about timing. This incredible release of water was happening while the comet was still very far from the Sun. At the time of these observations, 3I Atlas was about 2.9 astronomical units away. An astronomical unit, or AU, is the distance from the Earth to the Sun. So the comet was almost 3 times farther from the Sun than our planet is. At that distance, the Sun's energy is very weak. It is cold out there. For a normal comet from our solar system, that is way too cold for water ice to turn into gas in such large amounts. It was, as one scientist put it, way too much enthusiasm way too soon. Our comets need to get much closer, typically inside of 2 AU, before they start producing this much water. 3I Atlas was breaking a fundamental rule of comet behaviour, but the story got even stranger. As scientists looked closer at the chemical barcodes in the comet's light, they found another surprise. It was about the balance between 2 key ingredients, water and carbon dioxide. In most comets we know, water is the star of the show. Their ice is mostly frozen water, with a little bit of frozen carbon dioxide and other chemicals mixed in, like chocolate chips in a cookie. So when they heat up, you see a lot of water vapour and a little bit of carbon dioxide gas. But 3I Atlas was completely backward. Its carbon dioxide to water ratio was completely flipped. There was a huge amount of carbon dioxide, even more than the water in some measurements. This was not a water comet with a bit of carbon dioxide. It was a carbon dioxide comet with a bit of water. This strange chemical mix gave the comet a new nickname. Scientists started calling it the Soda-Fizz comet of the cosmos. The name is perfect. Think about a can of soda. The fizz comes from dissolved carbon dioxide gas. When you open it, the pressure is released and the gas rushes out. It seems that 3I Atlas works in a similar way. Its activity is not being driven by melting water ice, which is the normal engine for comets. Instead, it seems to be powered by its huge supply of frozen carbon dioxide. This substance turns from a solid to a gas at much colder temperatures than water. So, even in the cold, distant part of the solar system, the faint warmth of the sun was enough to make the carbon dioxide fizz. This fizzing gas was likely what was pushing out dust and water ice, causing the comet to be so active, so soon. Unlike other comets where water leads the show, on 3I Atlas, carbon dioxide was in charge. This was a fundamental difference that set it apart from everything in our solar system's catalogue. The composition was a direct message from its birthplace. A comet so rich in carbon dioxide must have formed in a place that was incredibly cold. Much colder than the region where our own comets were born. In the early days of our solar system, there was a temperature gradient. It was hot near the sun and got colder as you moved outward. Water could freeze into ice in the outer parts, but to get large amounts of solid carbon dioxide, you had to be very, very far out in the deep freeze. The chemistry of 3I Atlas suggested that its home system was either much colder overall, or that this comet was born in the extreme outer edges of its system and then thrown out into space. This single piece of chemical data opened up a whole new window into the diversity of planetary systems. The James Webb Space Telescope was crucial for these findings. Its ability to see in infrared light is perfect for detecting the signatures of molecules like water and carbon dioxide. It can measure their temperature and quantity with amazing accuracy. Without Webb, we would have known the comet was strange, but we would not have known exactly why. It was the combination of Webb's power and the work of ground-based telescopes that painted this detailed picture of a truly alien object. Science was working at its best, with different tools and teams coming together to solve a shared puzzle. The implications of this flipped ratio are profound. It challenges our models of how comets are made. We base those models on what we see in our own solar system. We assume that comets everywhere are probably made of similar stuff. 3I Atlas tells us that this assumption might be wrong. It tells us that there could be a whole class of carbon dioxide comets out there that are common in other star systems, but rare or non-existent in our own. It is like discovering a new type of tree in a forest you thought you knew completely. It forces you to rethink everything. This early activity and strange chemistry made 3I Atlas one of the most interesting comets ever studied. It was not just a visitor, it was a teacher. It was providing a lesson in cosmic chemistry, and the lesson was clear. Do not assume that your own backyard is representative of the entire universe. The universe is full of variety. The way planets and comets form around other stars can be wildly different from how they formed here. 3I Atlas was the proof, a fizzy, hyperactive snowball from another star, rewriting the rules of what a comet can be. The initial look was over. The comet was undeniably weird. Now scientists had to figure out why. What could make a comet behave like this? The puzzle of 3I Atlas just kept getting more complex. We knew it was from another star. We knew it was strangely active and had a weird chemical mix, but why? Why was it breaking all the normal comet rules? Why was it so active so soon? The answers to these questions would take us deeper into the science of comets and provide even more clues about the comet's mysterious origins. It was not enough to know that it was weird. Scientists needed to understand the physics behind the weirdness. Further studies of the comet only added to the mystery. Astronomers used a technique called polarimetry. This sounds complicated, but the idea is simple. It is about how light scatters off the dust particles in the comet's coma. It is similar to how polarized sunglasses work to cut down on glare. By looking at the polarization of the light from 3I Atlas, scientists can learn about the dust itself. They can get clues about the size, shape, and texture of the tiny dust grains that the comet is shedding. And, once again, 3I Atlas refused to be normal. The polarimetric observations showed that its dust scatters light in a way that does not match any known comet from our solar system. This strange signal could mean a few things. It might mean the dust grains are super fine, almost like smoke. Or it could mean they have a very complex, fluffy structure. Or it could even mean that the dust is made of a plain weird chemistry, with minerals that are not common in our part of the galaxy. The surprises did not stop there. While new observations were flooding in, a team of scientists had a clever idea. They decided to look back in time. They searched through old data from a space telescope called TESS. TESS stands for Transiting Exoplanet Survey Satellite. Its main job is to hunt for planets around other stars. But to do that, it takes pictures of huge patches of the sky for weeks at a time. The scientists wondered if TESS might have accidentally taken a picture of 3I Atlas long before it was officially discovered. They looked through the archives and they found it. TESS had seen the comet when it was much farther away from the Sun, and this old data held a shocking secret. 3I Atlas was already active 6 astronomical units from the Sun. That is about 560 million miles away. It was out past the orbit of Jupiter. To understand how truly strange this is, you need to know how normal comets behave at that distance. At 6 AU, the Sun is just a distant bright star. Its warmth is incredibly faint. Out there, most comets are in hibernation mode. They are frozen solid, inactive, and dark. They are just coasting through space, refusing to even acknowledge the Sun's existence. For a comet to be active at that distance is extremely rare. We have only seen a handful of comets from our own solar system do this. So, for an interstellar visitor to be this active, this far out, was a major discovery. It was not just a little weird, it was a true outlier. It was in a class of its own. So, what does this incredibly early activity tell us? It gives us a powerful clue about how and where 3I Atlas must have formed. For a comet to turn on this early, it must be made of materials that turn into gas at very, very low temperatures. We already knew it had a lot of carbon dioxide, which is one of these materials. But being active at 6 AU suggests it might have even more sensitive chemicals hidden inside. Things like frozen carbon monoxide or nitrogen, which can turn into gas with just a tiny hint of sunlight. These are called super volatile materials. The presence of these chemicals means that 3I Atlas must have formed in a place that was much colder and more chemically unusual than our own solar system's comet nursery. It was born in the deep, deep freeze. All of these clues, the weird dust, the activity at 6 AU, the carbon dioxide-rich composition, point to one exciting conclusion. This comet points to a completely different stellar system, a system with its own rules and its own special recipe for making comets. The place where 3I Atlas was born was not like the birthplace of our own comets. It had a different mix of chemicals, it had different temperatures. The way materials came together to form this icy body was unique. This is both exciting and confusing for scientists. It is exciting because it is a direct look at the variety of the galaxy, but it is confusing because it challenges all of our existing models. We have spent decades building up a picture of how comets should work, based on the thousands we have seen in our own solar system. Now, 3I Atlas has shown up and told us that our picture is incomplete. There is more out there than we ever dreamed of. The early activity is the key. It is the smoking gun that proves its exotic origin. It is one thing for a comet to have a strange chemical mix, but for it to behave in a way that is physically different from our comets is a much stronger piece of evidence. It is a fundamental difference in its nature. It is like the difference between a car that runs on gasoline and one that runs on electricity. They might both be cars, but their engines are completely different. 3I Atlas has a different kind of engine, an engine that can start up in the extreme cold of deep space. This realization sent a wave of excitement through the astronomical community. It meant that studying 3I Atlas was not just about studying a single weird object. It was about studying the process of planet formation in another star system. Comets are leftovers from that process. They are like the spare bricks and wood left over after a house is built. By studying the leftovers, you can learn a lot about how the house was constructed. 3I Atlas is a leftover from a house we have never seen before. And it is telling us that the builders used some very different materials. This single comet has opened a door to a whole new area of research. The study of interstellar comets is no longer just about finding them. It is about using them as probes that travel across the stars to bring us messages from other worlds. And the message from 3I Atlas is loud and clear. The galaxy is a very diverse place. The search through the TESS data was a brilliant piece of detective work. It showed the power of having archives of scientific data. Sometimes the most important discoveries are not made with new observations, but by finding new ways to look at old ones. The fact that TESS, a planet-hunting telescope, could provide a key clue about an interstellar comet shows how interconnected all areas of astronomy are. Every piece of data is valuable, and you never know when it might hold the key to a completely different mystery. The unusual dust properties also hint at a different formation environment. The way dust grains form depends on the temperature, pressure, and chemical composition of the disk of gas and dust around a young star. The unique signature of the dust from 3I Atlas is like a geological fingerprint. It tells a story of a different kind of planetary nursery. A place where the building blocks of planets were not quite the same as they were here. Maybe the star it came from had a different chemical makeup. Or maybe the dynamics of the disk were different. Whatever the reason, the result is a comet that is alien from its icy core all the way out to the tiny dust grains it sheds into space. Every part of it speaks of its foreign origins. The existence of 3I Atlas challenges us to be more open-minded. It is a perfect example of a scientific black swan, an event that is a complete surprise and that forces us to change our way of thinking. Before we started finding interstellar objects, it was easy to assume that our solar system was a good template for all the others. Now we know that's not true. We know that there is a vast range of possibilities out there, and we are just beginning to scratch the surface of understanding it. 3I Atlas is not just an object to be studied. It is a symbol of how much we still have to learn. It is a humble reminder that the universe is always bigger and stranger than we imagine. The puzzle of 3I Atlas's strange behavior demanded an explanation. Scientists could not just say it was weird. They had to figure out the science behind it. What makes Atlas so weird? Unpacking its gassy secrets meant coming up with theories that could explain its early activity and its strange chemical mix. These theories would need to obey the laws of physics, but also account for a comet that was clearly not from around here. The search for answers led scientists to explore the very heart of the comet itself. Let's start with the basic problem. Normally, water ice in a comet does not start turning into a gas in large amounts until the comet gets closer than 3 astronomical units to the Sun. This is a well-understood process. The bonds that hold water molecules together in ice require a certain amount of energy to break. Far from the Sun, there just is not enough energy to do that efficiently. The sunlight is too weak. But 3I Atlas did not care about these rules. It decided to wake up early and start causing problems for our neat and tidy theories much farther out. So, what could be happening inside this comet to make it so different? The top theory among scientists is that the comet has a large amount of super volatile chemicals lurking just beneath its surface. Volatile is a word for how easily something turns into a gas. Water is volatile, but not super volatile. Things like frozen carbon dioxide, or even better, frozen carbon monoxide and nitrogen are super volatile. These chemicals are so sensitive to heat that even the gentle warmth found in deep space was enough to make them pop. They are like a can of soda that has been shaken up and is ready to explode at the slightest touch. The theory is that 3I Atlas is full of these super volatile ices. Here is how this idea might work. Imagine the comet as it was travelling through the cold of interstellar space. It was completely frozen and inactive. But as it entered our solar system and started to get even a tiny bit closer to the Sun, this faint warmth began to heat up the comet's surface. This heat could travel a few inches or a few feet down into the comet's icy body. If it reached a pocket of frozen carbon monoxide or nitrogen, that ice would instantly turn into a gas. This would create a burst of high-pressure gas trapped under the comet's surface crust. This pressure would build and build until it became too strong for the crust to hold it in. At that point, the pressure from these escaping gases may have cracked the comet's outer crust, like a weak spot in a dam. This would create a vent or a fissure. Through this crack, the trapped gas could rush out into space. But it would not just be the super volatile gas that escaped. This powerful jet of gas would act like a sandblaster. It would tear away pieces of the surrounding ice and dust and throw them out into space as well. This process could have allowed even more gas, and eventually water, to escape much earlier than expected. The super volatile chemicals were not just adding to the gas, they were acting as an engine to kickstart the whole process, helping to expose the more stable water ice underneath. This theory neatly explains both the early activity and the strange chemical composition. The early activity is caused by the super volatile chemicals that can turn to gas in the extreme cold. The high amount of carbon dioxide we see is because the comet is just naturally rich in that material. It is a simple and elegant explanation that fits most of the facts. But it is not the only idea. There is another possibility to consider. This other possibility is that its nucleus, which is the solid core of the comet, might be a crumbly mess. The nucleus of a comet is not a solid block of ice like an ice cube. It is more like a pile of gravel and snow loosely held together. But some comets are more tightly packed than others. It is possible that the nucleus of 3I Atlas is extremely porous or fractured. Porous means it has lots of tiny holes and empty spaces in it, like a sponge. A fractured nucleus would have large cracks running deep into its interior. If the nucleus is very porous or has deep cracks, it could also explain the early activity. A crumbly, porous structure would allow sunlight to sneak deeper inside the comet and heat things up much faster than usual. On a normal, compact comet, sunlight only heats the very top layer. But on a porous comet, light could penetrate deeper, warming up a much larger volume of ice. This would allow ices, even water ice, to turn into gas more efficiently, even when the comet is far from the sun. It is like the difference between trying to melt a solid block of ice and trying to melt a pile of crushed ice. The crushed ice melts much faster because the heat can get to all the little pieces. A porous nucleus would work in a similar way. It is also possible that both of these theories are true at the same time. 3I Atlas could be both rich in super volatile chemicals and have a very porous, crumbly structure. This combination would make it a truly hyperactive comet. The porous structure would allow the faint heat of the sun to get deep inside. This heat would then activate the super volatile ices, creating powerful jets of gas that further break apart the weak structure of the nucleus. It would be a feedback loop of activity. Heat causes gas release, which breaks the comet apart, which exposes more ice to the heat, which causes more gas release. This could explain the incredible level of activity seen so far from the sun. Unlocking these secrets is key to understanding where 3I Atlas came from. A comet that is rich in supervolatiles like carbon monoxide must have formed in one of the coldest places imaginable. A place where even those gases could freeze solid and become part of the building, blocks of a new world. A comet with a very porous structure might tell us about the speed at which it formed. Perhaps it came together very gently, allowing lots of empty space to remain between the icy grains. Each of these physical properties is a clue that helps us build a picture of its home system. Scientists are working hard to figure out which of these theories is correct. They are using computer models to simulate how a comet with these properties would behave as it gets closer to the sun. They are comparing these models to the real observations of 3I Atlas. By seeing how the comet changes over time, they can test their ideas. For example, if the comet suddenly has a huge outburst of activity, it might support the idea of a pocket of super volatile gas bursting through the crust. If the activity slowly and steadily increases, it might support the idea of a porous nucleus heating up. The comet's behavior is the ultimate test of these theories. As it continues its journey, it will provide the data we need to finally understand its gassy secrets. The mystery of what makes Atlas so weird is slowly being solved, one observation at a time. The answer is locked inside its icy core, a core that was formed in a realm of unimaginable cold, light years away from our sun. No matter which specific theory turns out to be correct, they all lead us back to the same place. They all point to a comet that is fundamentally different from our own. Its weirdness is not just a surface-level quirk. It is a deep property that comes from its very formation. This is why it is so important. This is why every astronomer is watching. Because this comet carries a message from a place we have never been. It has a passport from another star system, and by studying it, we are learning about its true home. It is worth repeating this central idea. No matter the detailed explanation for its weirdness, one thing is absolutely clear. 3I Atlas is giving us a rare and precious peek at what comets are made of in other solar systems. We have studied thousands of comets in our lifetimes, but they have all been from here. They are all members of our own solar family. This is the first time we have had such a good look at a comet from a completely different family. And it is teaching us that not all families are the same. This visitor is showing us that what we consider normal is just our own local custom. When we look at the chemistry of 3I Atlas, we can state with confidence that its composition is wildly different from what we're used to seeing around our sun. The high concentration of carbon dioxide is the most obvious difference, but there are likely other, more subtle differences in the types of minerals in its dust and the ratios of other exotic ices. Each chemical is a clue. Together they paint a picture of a very different birthplace. It is like a geologist studying a rock. A geologist from Earth can tell you a lot about our planet just by looking at a piece of granite. But if you gave them a rock from Mars, they would see different minerals and a different history. 3I Atlas is that rock from Mars. It is a sample of extraterrestrial geology, but from much, much farther away. A carbon dioxide-dominated comet like 3I Atlas signals one crucial fact. This traveller was born way out in the deep freeze suburbs of a distant protoplanetary disk. A protoplanetary disk is the giant spinning cloud of gas and dust around a young star where planets and comets are born. Just like in our solar system, these disks have different temperature zones. There is a hot region close to the star, a warmer region farther out, and an extremely cold region at the very edge. For a comet to be so rich in carbon dioxide and possibly other super volatile ices, it must have formed in that outermost coldest region. A place where the temperature was low enough for these gases to freeze into solid form. We can compare this to the places where our own comets are thought to form. Most comets from our solar system are believed to have formed in a warmer, coffee-drinking region of our own protoplanetary disk. This region was still cold enough for water to freeze, but not cold enough for huge amounts of carbon dioxide or carbon monoxide to freeze. So our comets ended up being mostly water-based. The birthplace of 3I Atlas must have been a very different environment. It was an ice cream parlour compared to our coffee shop. This fundamental difference in formation temperature is what led to the fundamental difference in composition we see today. This idea is strongly reinforced by the comet's path. We know for a fact that it is not from here. Its interstellar trajectory is the ultimate proof. The math is undeniable. It is moving too fast and on the wrong path to be a member of our solar system. This makes it the cosmic equivalent of a tourist with a very foreign passport. The passport tells you where they are from. For 3I Atlas, its path is one part of its passport, and its chemical composition is the other. Both are stamped with the seal of another star system. They work together to tell a consistent and compelling story. This is why interstellar objects are so incredibly valuable. We cannot travel to other star systems to study them up close. The distances are just too vast. The nearest star is more than 4 light-years away. Our fastest spacecraft would take tens of thousands of years to get there, so we have to wait for pieces of those star systems to come to us. And that is exactly what 3I Atlas is. It is a free sample, a piece of another world, delivered right to our doorstep by the forces of gravity. It is a chance to do extraterrestrial science without ever leaving home. By studying this passport, we can start to ask some very deep questions. What was the star that 3I Atlas used to orbit like? Was it bigger or smaller than our Sun? Hotter or cooler? Did it have giant planets that threw this comet out into space? Was its protoplanetary disk bigger or smaller than ours? Did it have the same chemical ingredients to begin with? The chemistry of 3I Atlas holds clues to all of these questions. It is a message in a bottle, thrown into the cosmic ocean millions of years ago, and we are the lucky ones who get to find it and read the message inside. This concept changes how we view the galaxy. It is not just a collection of isolated star systems. It is a place where materials are exchanged. Objects are constantly being thrown out of their home systems and sent on journeys through interstellar space. Most of them will travel forever in the dark, but every now and then one of them will, by pure chance, pass through another star system like ours. These visitors stitch the galaxy together. They show us that we are all made of the same basic star stuff, but that stuff can be mixed together in a wonderful variety of different ways. So, when we look up at 3I Atlas, we are not just seeing a comet, we are seeing a representative, an ambassador from another stellar nation. It cannot speak to us in words, but it speaks to us in the language of physics and chemistry. And what it is telling us is that the universe is far more diverse and interesting than we ever imagined. Its weirdness is not a flaw. It is its most important feature. It is the thing that tells us the most about its true home. A home that is colder and perhaps stranger than we can even comprehend. This visitor has given us a priceless gift. The gift of a new perspective on our place in the cosmos. And it reminds us that there is always more to explore and more to learn. The universe is waiting. The information we can gather from this traveller is not just about its past, it is also about our own. By seeing what is different about 3I Atlas, we learn more about what is special about our own solar system. It provides a point of comparison. It helps us understand the specific conditions that led to the formation of our own comets, our own planets, and ultimately ourselves. Every piece of data from this interstellar guest helps us to better understand the story of our own cosmic home. It is a piece of a puzzle that is far bigger than any one star system. It is the puzzle of how worlds are made across the entire galaxy. The story of 3I Atlas is written not just in its gas, but also in its dust. the tiny solid particles that fly off the comet, are just as important as the ice. These dust grains are like tiny time capsules. They carry the chemical history of the place where they were born. By studying this dust, scientists can get another kind of look at the comet's home system. They are like cosmic fingerprints. And the fingerprints of 3I Atlas do not match any of the locals. We have already mentioned that the way the comet's dust scatters light is weird. This property is called polarization. It is a fancy term for how light waves wiggle. Sunlight is normally unpolarized, meaning its waves wiggle in all directions. But when that light bounces off a surface like a dust grain, it can become polarized, meaning the waves start wiggling in a more organized way. By measuring this polarization, scientists can learn about the surface that the light bounced off of. And the polarization of 3I Atlas refuses to match the patterns we see in comets from our solar system. This is a very strong clue that its dust is fundamentally different. So, what does this strange polarization mean? There are a few possibilities. It could mean that its dust grains are structured differently. The dust from our comets is often described as being like fluffy little snowballs made of rock and organic materials. Maybe the dust from 3I Atlas is more compact, or has a different shape. The dust grains could also be sized differently. Perhaps they are much smaller or much larger on average than the dust from our comets. Or, and this is the most exciting idea, the dust could be made of minerals that we barely see around our solar system. The chemistry of the rock itself could be alien. This is of huge scientific importance. The reason is that dust grains basically carry chemical selfies of their home systems. Think about it this way. The dust in a protoplanetary disk is what eventually clumps together to form planets and asteroids and comets. The specific minerals that make up that dust depend on the chemistry of the gas cloud that the star system formed from. So if we can analyze the dust from 3I Atlas, we're essentially analyzing the raw building materials of its home solar system. We are looking at a sample of the stuff that its own planets might be made of. Based on these dust clues, scientists might actually be able to piece together what kind of environment shaped it. For example, if they find certain minerals that only form at very high temperatures, it could tell them about violent events that happened near its parent star. If they find an abundance of certain elements, it could tell them about the chemical composition of the star itself. Each dust grain is a tiny piece of a giant puzzle, and with enough pieces, a picture of the comet's home system could start to emerge. It would be a fuzzy picture, to be sure, but it would be a picture of a place light years away that we could get in no other way. Now, whenever a strange object from space shows up, some people's minds jump to one exciting possibility. Maybe it is aliens. This idea was made famous recently by a scientist named Avi Loeb, who suggested that our first interstellar visitor, Oumuamua, could have been an alien technology. It is a fun and exciting idea to think about. Could 3I Atlas be an alien probe? The short answer is almost certainly no. All the evidence we have points to a totally natural origin for 3I Atlas. It is behaving like a comet, just a very weird one. It is releasing gas and dust in a way that is consistent with the laws of physics. There is nothing about it that requires an artificial explanation. So, if it is not aliens, what is it? Let's summarize what we know. It is a highly volatile, chemically unique snowball that was forged around a far-off star. Its strangeness is not a sign of technology. It is a sign of natural variety. It is a testament to the fact that nature can be more creative and surprising than we often give it credit for. The universe does not need to build things the same way everywhere. 3I Atlas is a perfect example of this. It is a product of a different set of initial conditions, a different recipe. And by studying that recipe, we learn more about the cosmic cookbook. The study of its dust is one of the most exciting frontiers in this investigation. Some missions in the past have actually flown through the tails of comets from our solar system and captured dust particles to bring back to Earth. We cannot do that with 3I Atlas, as it is moving too fast and its path was not known far enough in advance to plan such a mission. But we can do the next best thing. We can use our telescopes to study the dust from afar. We can analyze the light it reflects. We can look at its color. We can look at its temperature. We can use all of these remote sensing techniques to squeeze every last drop of information out of these tiny, precious grains of dust. The fact that its dust is different is a critical piece of the story. It shows that the comet is alien through and through. It is not just the ice that is different. The rock is different too. This reinforces the idea that it comes from a truly different environment, an environment with a different chemical heritage. It is another stamp on its interstellar passport, another confirmation that we are looking at something genuinely new, something that has the potential to rewrite our understanding of how solar systems are put together. The dust of 3I Atlas is a trail of breadcrumbs, and if we follow it carefully, it might just lead us to a better understanding of our place in the galaxy. The analysis of these cosmic fingerprints is a slow and careful process. It requires complex computer models and many hours of telescope time, but the payoff is huge. It is a chance to do a kind of interstellar geology, a chance to study the rocks of another solar system. This is a dream come true for planetary scientists, and it is all thanks to a chance visit from a weird, dusty snowball that was thrown out of its home millions of years ago. Its long and lonely journey has finally brought it to a place where its secrets can be revealed. We are the lucky ones who get to be here to see it happen. The journey of 3I Atlas has been a story of scientific discovery, full of puzzles and surprises, but the most exciting chapter is still to come. So far we have been watching the comet as it approaches the Sun, but soon it will face its greatest challenge. It will have to fly through the most dangerous part of our solar system. This is what astronomers call the Sun's Gauntlet, and what happens during this fiery challenge will be the climax of the story. The real suspense is building for a specific date. On October 29th, 3I Atlas will make its closest solar encounter. This moment is called Perihelion. On that day, the comet will get within 0.53 astronomical units of the Sun. That's about half the distance between the Earth and the Sun. To us, that might still sound like a long way away. But for a fragile comet made of ice and dust, that is incredibly close. It is the hot seat moment, literally. The comet will face the full, ferocious power of our star. The heat will be intense, the radiation will be punishing, and the Sun's immense gravity will be pulling and twisting on its small, fragile body. This will be the ultimate test of its strength and stability. Astronomers all over the world are eagerly watching. They are getting their telescopes ready. It is like preparing popcorn for a cosmic movie. No one knows for sure what is going to happen. Comets are famously unpredictable, and an interstellar comet like this one is a complete wild card. But based on what we know about comets, there are three main outcomes that are possible. Each one is dramatic in its own way, and each one would teach us something valuable about this strange visitor. The first possibility is that the comet could have a massive outburst. As the intense heat from the Sun hits the comet's surface, it could cause a huge sudden release of gas and dust. It might suddenly throw a flashy cosmic tantrum. This could happen if a large area of fresh ice is suddenly exposed to the sunlight, or if a huge pocket of trapped gas finally breaks free. If this happens, the comet could become dramatically brighter in a very short amount of time. It might grow a spectacular bright tail that could be seen with telescopes all over the world. This would be the most visually stunning outcome. It would be a fantastic show, and for scientists, it would be a treasure trove of data. An outburst would release huge amounts of material from deep inside the comet, giving us our best look yet at its true, pristine composition. The second possibility is more destructive. The intense heat and gravity from the Sun could be too much for the comet to handle. It could cause it to crack apart like a cookie that got too warm. The nucleus of a comet is not a solid rock. It is a loose collection of ice and dust held together by its own weak gravity. The tidal forces from the Sun, which are the stretching forces of gravity, could pull the nucleus apart. The rapid heating could also cause stresses that fracture the comet from the inside out. If this happens, we would see the single comet break up into a string of smaller fragments. This happens to comets from our own solar system sometimes. It is a dramatic and violent end. For 3I Atlas, a breakup would also be scientifically interesting. It would expose the interior of the comet, allowing us to see what it is like on the inside. The third possibility is that the comet could simply survive. It might be strong enough to withstand the heat and gravity. It might casually stroll past the Sun like it is no big deal. In this case, it would get brighter as it got closer, and then slowly fade as it moved away. It would keep its form and continue on its journey out of the solar system. Now, scientists think this is the least likely outcome. Given how active and weird the comet has been so far, it seems likely that something dramatic will happen. But we should never underestimate a comet's ability to surprise us. Comets love surprises, so a smooth survival is still on the table. Whatever happens, the perihelion pass will be a critical moment. It is the point of maximum stress and maximum activity. It is our best chance to learn the final secrets of 3i Atlas. The changes that happen to the comet during this close approach will tell us about its internal strength, its structure, and how its exotic materials react to extreme heat. It is a one-of-a-kind experiment that nature has set up for us. We are just the lucky observers. The anticipation in the scientific community is palpable. Emails and messages are flying back and forth between astronomers as they coordinate their observation plans. Everyone wants to have their telescope pointed at the right place at the right time. They will be using every technique at their disposal. They will be taking pictures. They will be measuring the composition of the gas. They will be studying the dust. They will be trying to measure the size and shape of the nucleus. It will be an all-out effort to capture every possible piece of information during this crucial event. The fate of 3i Atlas hangs in the balance. Will it put on a brilliant show? Will it die in a blaze of glory? Or will it quietly survive its trial by fire? We do not have to wait much longer to find out. The date is set. The comet is on its way. The sun is waiting. The gauntlet has been thrown down. The final act of this cosmic drama is about to begin. The whole world will be watching to see what happens when this messenger from another star meets the fire of our own. The outcome will be written in the light that travels from the comet to our telescopes, telling the final chapter of its visit to our solar system. The impending showdown between 3i Atlas and the Sun is not just a spectator sport. It is a massive scientific operation. An army of instruments, both on Earth and in space, is being prepared to watch the show. These are the Watchers, and their job is to spy on every moment of the comet's fiery pass. Each telescope and spacecraft has a unique role to play, and together they will give us a complete picture of this incredible event. Scientists know that whatever happens after perihelion will be crucial. The close pass with the Sun is like putting the comet in an oven. The after pictures are what will tell us how it cooked. That is when we will gather the best data and hopefully learn the juiciest secrets. By comparing the comet before and after its closest approach, we can see exactly what effect the Sun's heat and radiation had on it. This is where some of our most advanced space technology will come into play. One of the key players in this watch party is a European spacecraft called JWST. The name stands for Jupiter Icy Moons Explorer. As its name suggests, its main mission is to travel to Jupiter and study its giant icy moons. But right now, JWST is still on its long journey to the outer solar system, and by a wonderful coincidence of timing and position, it is in the perfect place to watch the 3i Atlas show. At the time of the comet's perihelion, the JWST spacecraft will be on the far side of the Sun from us. This position means that JWST is perfectly placed to watch what happens after Atlas swings around the Sun. From our point of view on Earth, the comet will disappear behind the Sun for a little while during its closest approach. We will lose sight of it, but JWST will be able to see it the whole time. It will have a grandstand view of the comet as it emerges from its trial by fire. It will be able to see if it broke up, if it had an outburst, or if it survived intact. This unique viewpoint is incredibly valuable, but there is only one catch. The JWST spacecraft is currently having a small technical problem. Its main high-speed antenna did not deploy correctly. It is stuck, so the spacecraft has to use its backup slower antenna to send data back to Earth. This means that the science updates from JWST will arrive fashionably late. The incredible pictures and data it collects during the perihelion pass will have to be stored on board the spacecraft and sent back slowly, bit by bit. We will probably not get to see them until sometime in early 2026. Spacecraft have communication issues too, apparently. It is a small frustration, but the data will be worth the wait. But do not worry. We will not be completely in the dark while we wait for JWST's data. Back here at home, we have plenty of other eyes on the sky. The James Webb Space Telescope and the Hubble Space Telescope will be leading the charge. These two titans of astronomy will be watching the show in something close to real time. Webb, with its powerful infrared vision, will be able to track the heat and the chemical changes in the comet's coma. Hubble, with its sharp vision in visible and ultraviolet light, will be able to take stunning, detailed pictures of the comet's structure and any tail that develops, and they will not be alone. A whole army of ground-based telescopes will join the effort. From mountaintops in Hawaii, Chile, and all around the world, giant telescopes will be pointed at 3i Atlas. These telescopes have a big advantage. They are huge. Their giant mirrors can collect a lot of light, allowing them to see faint details and perform very sensitive measurements. They will be working together, coordinating their observations so that the comet is being watched around the clock as the Earth turns. What will all of these telescopes be looking for? They will track every tiny change in the comet's coma. They will watch to see if it gets bigger or smaller, or if its shape changes. They will use spectroscopy to watch for every chemical shift in the light spectrum. This will tell them if new types of gas are being released from the comet's interior as it heats up. And of course, they will be watching for any dramatic outburst if 3i Atlas decides to throw one. If the comet brightens suddenly, they will be ready to take rapid-fire observations to capture the event as it unfolds. It is a global, coordinated effort, one of the biggest observing campaigns ever organised for a comet. This multi-pronged approach is the best way to do science. Each telescope provides a different piece of the puzzle. Webb gives us the chemistry, Hubble gives us the sharp pictures, the ground-based telescopes give us constant monitoring, and JWST gives us a unique viewpoint that no one else has. By combining all of this data, scientists will be able to build a complete 3D picture of the comet and how it responds to the sun's power. The challenge is immense. The comet is moving fast. Things could change in an instant. The astronomers and engineers who run these telescopes have to be at the top of their game. They have to point their instruments with pinpoint accuracy. They have to time their observations perfectly. It is a high-pressure situation, but it is also incredibly exciting. This is why people become astronomers. It is for moments like this. A chance to witness a unique cosmic event and be the first to see the data that will unlock its secrets. The watchers are ready. The telescopes are pointed. The stage is set. Now, all we can do is wait for the show to begin. After the comet's dangerous and fiery close pass with the Sun, the next chapter of its story will begin. What happens next for Atlas? The period after perihelion will be just as important as the event itself. It will be a time for observation, for reflection, and for putting all the clues together. If the comet survives its encounter, it will give us even more opportunities to learn its secrets. Let's assume for a moment that 3i Atlas makes it through its fiery test. If it survives its close pass with the Sun, it should reappear in our skies in early December. After disappearing into the Sun's glare for a few weeks, it will emerge on the other side, visible in our morning sky before sunrise. This will be a tense time for astronomers. They will be waiting eagerly to see if it comes back, and what it looks like if it does. Will it be a single object, or a chain of fragments? Will it be brighter or fainter than before? Its reappearance will be the first clue to its fate. If it does come back, we know its path. After swinging around the Sun, it will begin its long journey back out into the void. On its way out, it will glide past Earth at a comfortable distance of 270 million kilometers. That is about 168 million miles. Now that might sound close, but in space terms it is very, very far away. So there is no need to panic. The comet poses absolutely no threat to our planet. That is basically across town on a galactic map. We are perfectly safe. But this safe flyby gives scientists an incredible opportunity. The comet's comeback tour provides researchers with a perfect before and after comparison. We have all this amazing data on what the comet was like on its way in. We know its composition, its activity level, its dust properties. After it passes the Sun, we can take all the same measurements again. By comparing the before data with the after data, we can see exactly how the comet has changed. It is a controlled experiment on a cosmic scale. What is the goal of this comparison? The goal is to see how solar heat transforms material that formed around a totally different star. We have a good idea of how comets from our solar system react to the Sun. We have seen them get brighter, grow tails, and sometimes break apart, but we have never been able to see this happen to a pristine piece of another solar system. The materials in 3i Atlas are alien to us. How will its strange carbon dioxide-rich ice react to the intense heat? How will its unique dust grains be affected? Will the heat cause its internal structure to change? This is the kind of experiment that you simply cannot run in a lab, even the fancy ones. We cannot create a piece of another solar system and blast it with a star's worth of energy. We have to let the universe do the experiment for us. 3i Atlas is that experiment. Its journey past the Sun is a once-in-a-lifetime chance to see alien matter being processed by our own star. The results will be invaluable. They will help us understand the physics of comets better, and they will give us more clues about the strength and structure of this mysterious object. If the comet survives and we can study it on its way out, we can answer some key questions. For example, Did the close pass with the Sun blow off all of the super volatile chemicals from its surface? If so, we would expect to see its activity change. Maybe it will become less active on its way out, or maybe the water ice will take over as the main driver of its coma. This would help confirm our theories about what is powering it. We could also see if its dust properties change. Did the intense heat alter the structure or composition of the dust grains? Did the before selfie and the after selfie look different? Even if the comet breaks apart, that is still a fantastic scientific result. By watching the fragments, we can learn about the comet's internal strength. Was it as weak and crumbly as some theories suggest? We could also get a look at material from the comet's core that has never been exposed to sunlight before. This pristine, ancient material would be a scientific treasure. It would be our best look yet at the true original building blocks of this interstellar object. So, in a way, scientists cannot lose. Whether it survives or breaks up, we're going to learn something amazing. The period after perihelion will be a busy time for the world's telescopes. They will track the comet as it moves away from the Sun and past the Earth. They will continue to take spectra, measure its brightness, and study its dust. The data will pour in, and scientists will begin the careful work of analysing it all. They will be looking for changes, big and small. Every detail will be important. Every change will be a clue. The story of 3I Atlas will not end at perihelion. In many ways, that is just the beginning of the final chapter. The real understanding will come in the weeks and months that follow, as we piece together the full story of its journey through the heart of our solar system. The story of what happens next for Atlas is the story of what we will learn from its incredible voyage. The journey of 3I Atlas is a captivating story in itself, but it is also part of a much larger narrative. To truly understand its importance, we have to zoom out and look at the big picture. Why do interstellar visitors matter so much? The answer is that they are more than just cosmic curiosities. They are fundamental keys to understanding our galaxy and our place within it. They are messengers that carry clues about some of the biggest questions in science. The stakes here are bigger than this single visitor. Every time we find an object like 3I Atlas, we add a crucial piece to a giant puzzle. With 3I Atlas joining Oumuamua and 2I Borisov, we now have a small but growing family of interstellar visitors. With this family, scientists are starting to piece together how debris travels between star systems. We are beginning to get an idea of how many of these travellers are out there, what they are made of and where they come from. It is like being a biologist who has only ever studied animals in one forest. If you suddenly get visitors from 3 different forests around the world, you can start to build a much bigger picture of what life on the planet is like. These objects are also helping us understand how planetary formation might differ throughout the galaxy. We have one example of how to build a solar system, our own. But is our way the only way? Is it the most common way? 3I Atlas, with its strange composition, strongly suggests that the answer is no. It shows us that other star systems can have very different chemical recipes. This has huge implications. It means that the types of planets that form around other stars could be very different from the ones we know. Maybe in a carbon-rich system like the one 3I Atlas seems to come from, you get carbon-rich planets. Maybe the possibilities for worlds out there are far more diverse than we ever imagined. You can think of these comets and asteroids as cosmic hitchhikers. They are pieces of their home, systems that got a lift from gravity and are now travelling the galactic highways, and they are possibly carrying clues about how worlds are born, evolve, and sometimes fling their leftovers our way. By studying these hitchhikers, we can learn about the places they have been without ever having to go there. They are our cheapest and easiest way to explore the galaxy. They are probes, built by nature and sent to us free of charge. We just have to be smart enough to study them when they arrive. The study of these objects also has a very practical side. Each interstellar detection helps scientists improve their early warning systems. The same telescopes that found 3I Atlas are the ones we use to look for asteroids that could be a danger to Earth. The more we use these systems, the better we get at finding faint, fast-moving objects. The techniques and software that are developed to find interstellar visitors can be used to make our planetary defense systems more effective. So, studying these objects from far away actually helps us to be safer here at home. It also prepares us for the future. The next time a mysterious object dives into our solar system, we will be ready to grab our telescopes faster. We will know what to look for. We will have better models and theories to test. The discovery of Oumuamua caught us by surprise. We did not get a good look at it before it was gone. With 2i Borisov, we did a little better. With 3i Atlas, we are doing better still. We are getting better at this. We are learning how to react quickly and organize global observation campaigns. Each visitor is a fire drill. It helps us practice for the next one. And the more we practice, the more we will be able to learn. This field of study is still very new. Just a decade ago, we had not found any interstellar objects. Now, we have 3. This suggests that these visitors might be more common than we thought. As our telescopes get more powerful, we will likely start finding them more and more often. We may be entering a golden age of interstellar object research. 3i Atlas is at the forefront of this new scientific revolution. The things we learn from it will lay the groundwork for decades of future research. This big picture is what motivates the thousands of scientists who are studying this comet. They are not just interested in one weird snowball. They are interested in what that snowball represents. It represents a connection to the wider galaxy. It represents the incredible diversity of nature, and it represents the endless human quest for knowledge. To understand our universe, we must understand all of its parts, not just the ones in our own backyard. Interstellar visitors like 3i Atlas are our guides to that wider universe. They are our messengers, and we have to listen very carefully to the stories they have to tell. The story of 3i Atlas is not just its story, it is ours. It is the story of how we are slowly but surely beginning to understand our place in the cosmos. It is a story of connection, of diversity, and of discovery. The study of interstellar objects is about more than just understanding the cosmos. It is about preparing for the future of space exploration. Each visitor that passes through our solar system is a lesson. It teaches us about what is out there and how we can best prepare for the next alien visitor. The lessons we learn from 3i Atlas will help shape the future of how we study these objects, and could even lead to incredible new missions. Let's restate a key idea. Every time one of these interstellar visitors swoops through our neighbourhood, we learn more. We are constantly updating our knowledge. Specifically, we are learning about how many of them are out there. Are there billions of these objects wandering the galaxy for every star? Or are they more rare? The more we find, the better our estimate becomes. We're also learning what they're made of. Oumuamua was rocky. Borisov was like one of our comets. Atlas is a carbon dioxide-rich weirdo. This growing collection of data points is showing us the range of possibilities, and we are learning how they react when the sun cranks up the heat. This tells us about their internal structure and strength. All of this is vital information. As our detection technology keeps improving, we are going to find more and more of these objects. The Atlas survey that found 3i Atlas is getting better all the time, and in the near future, a new, even more powerful observatory is coming online. The Vera C. Rubin Observatory in Chile will be able to scan the entire sky every few nights with incredible sensitivity. Scientists expect it to find dozens, maybe even hundreds, of interstellar objects over its lifetime. We're about to go from a trickle of these visitors to a flood, and when that happens, we need to be ready. Being ready means we might soon be able to study future cosmic travellers up close. Right now, we are limited to studying them from afar with telescopes, but imagine if we could send a spacecraft to fly right up to one of these objects, to take close-up pictures, to analyse its gas and dust directly, to maybe even land on it. This is the ultimate goal for many planetary scientists. The lessons we are learning from 3i Atlas are helping us to design such a mission. For example, we are learning how fast these objects move and what kinds of orbits they have. This tells us how fast our own spacecraft would need to be to catch up to one. We are also learning about the kinds of instruments we would need to study their weird chemistry. This leads to a very exciting possibility. We might one day be able to send a dedicated spacecraft to chase one down for a proper meet and greet. Such a mission would be a huge technological challenge. The object would be moving very fast, so we would need a very powerful rocket and a very fast spacecraft. We would also need to detect the object very early, when it is still far away, to give us enough time to launch our chase mission. This is where the improved survey telescopes come in. If the Rubin Observatory can find an interstellar object when it is still years away from the Sun, we might just have enough time to get a spacecraft there to greet it. This vision emphasizes the long-term impact of studying objects like 3i Atlas. It is not just about the science we get today. It is about building the knowledge and capabilities we need for the ambitious space exploration of tomorrow. Each interstellar object is a stepping stone. Oumuamua taught us that they can be very strange. Borisov taught us that they can also be familiar. 3i Atlas is teaching us about the incredible chemical diversity that is possible. The next one will teach us something new again, and all of these lessons will be fed into the designs for future missions. Imagine that future. A new interstellar comet is detected. It is still far away beyond the orbit of Saturn, but we know its path precisely. On Earth, a rocket is waiting. It is a rapid response interceptor designed for just this moment. It launches, carrying a small smart probe. The probe travels for years, but it finally catches up to the visitor in the cold, dark space of the outer solar system. It then spends months flying alongside the comet, studying its every detail as it makes its journey toward our Sun. The data it sends back would be revolutionary. It would change our understanding of the universe forever. This might sound like science fiction, but it is a future that is getting closer every day, and the study of objects like 3i Atlas is what is making it possible. We are laying the groundwork. We are taking the first steps. The astronomers who are patiently tracking 3i Atlas tonight are not just studying a comet. They are scouts for the future of human exploration. They are mapping a new frontier, a frontier that is not a place, but a new class of object. The study of these interstellar visitors is pushing our technology, challenging our theories, and inspiring the next generation of scientists and explorers. The legacy of 3i Atlas will not just be the papers written about it. Its legacy will be seen in the missions we fly and the discoveries we make for decades to come. It is helping us prepare for a future where meeting a visitor from another star is no longer a surprise, but a planned and celebrated event. The story of 3i Atlas is reaching its climax. We have followed its journey from a faint dot of light to a full-blown scientific phenomenon. We have explored its strange behavior, its alien chemistry, and the secrets it holds about its distant home. Now, as it prepares for its fiery encounter with our Sun, it is time to reflect on what makes this comet so special. Its journey will soon be over, but its impact on science is just beginning. The legacy of 3i Atlas will be that it helped to rewrite the Comet rulebook. Let's conclude by emphasizing this simple, powerful fact. 3i Atlas stands out from every comet we have ever seen. It is not just a little different, it is fundamentally different. When you have looked at thousands of objects and they all follow a certain set of patterns, and then one comes along that breaks all those patterns, you have to pay attention. That is what 3i Atlas has done. It has forced us to stop and rethink our most basic assumptions about what comets are and how they work. Let us reiterate its unique characteristics. It is a list of oddities that makes it a true one-of-a-kind object, at least for now. From its oddball chemistry, with its huge amounts of carbon dioxide, to its way too early activity, starting up in the cold darkness beyond Jupiter's orbit. Everything about it is strange. Its dust scatters light in a way we have never seen. Its coma appeared bright and compact without a tail early on. It is like a walking, or rather flying, clue from another star system entirely. It is a perfect example of how wonderfully diverse the universe can be. This is why its upcoming moment at perihelion is so much more than just a dramatic plot point for astronomers. It is not just about seeing a pretty show in the sky. This is a critical scientific experiment. The data that will be collected as the comet faces the full force of the Sun is priceless. The results from its solar encounter could change how we investigate interstellar objects for years to come. What we learn from this event will shape future research and even the design of future space missions. For example, if 3i Atlas breaks apart very easily, it will tell us that comets from these cold, carbon-rich environments might be structurally very weak. This would be vital information for any future mission that plans to get close to one of these objects. If it has a massive outburst of specific chemicals, it will give us an unprecedented look at the pristine material from its core. This would be like getting a clean sample of the protoplanetary disk it formed in. Every possible outcome will teach us something new and important, and that new knowledge will be added to the growing rulebook for interstellar objects. This comet has already changed the conversation. Before 3i Atlas, we had two examples of interstellar visitors. One was a weird rock, and one was a pretty normal comet. It was easy to think that these were the only two options. 3i Atlas has shown us that there is a whole spectrum of possibilities in between. It has opened our minds. It has made the problem more complex, but also much more interesting. It underscores that we cannot just have one theory for interstellar objects. We are going to need a whole set of theories to explain the variety we are starting to see. So, in the end, 3i Atlas is not just a passing curiosity, it is a fundamental teacher. It is teaching us about the diversity of the cosmos. It is teaching us about how planetary systems form in other parts of our galaxy. And it is teaching us how much we still have to learn. Its legacy will be the new questions it has forced us to ask, and the new avenues of research it has opened up. The story of this strange snowball from another star will be told in textbooks for generations to come. It will be remembered as the visitor that showed us the universe was far stranger and more wonderful than we had ever imagined. It rewrote the rules, and for a scientist there is no greater gift than that. Don't miss our next update on 3i Atlas as we await its dramatic encounter with the Sun. Hit that notification bell and let us know what you think might happen.